6 class, right? Day 6, and today's date is 3/9/22. Okay. So in last class, we have seen about the SCD tabs, right? So what is slowly changing dimensions and types of the slowly changing dimension. So we'll go with the one by one. So we will just repeat the last class, and then after that we'll go with the today's class. Okay. So type 1. What is type 1? What is type 1? SCD type 1. See,
Having
any,
current
yes,
dimensions.
exactly. So just repeat these words when you are going with the SCD type 2 explanation or something like that. I will explain you like current data. Okay. Current data for the type 1. And where you go to type 2, this is a current plus history data. Okay. And where it comes to type 3, it is uh, type 3, that is current plus partial history. Okay. And also there is a type 4 and type 6. Type 4 is nothing but will maintain this separate record. Okay. Separate tables for current current plus history, right? Also, we'll maintain a delete records as well. For that as well, we'll maintain a separate tables. Okay, that is called history. Okay, and tab 6 is nothing but it is 1 plus 2 plus 3 of types. Okay, so these three combination of these three types, if you are going to use, so that is known as a type 6. But it has never happened like in the projects never use this type 6. Okay, and type 4 also there is a huge maintenance issue. They will maintain a lot of memory. The tables will be separate, having a separate table and separate table structure is nothing but, and also it is maintaining like a redundancy data, right? So that is what like this type 4 is also, yeah, it will be like it is using the performance, it is causing the performance issue for our informatica. So when it comes to the type 1, it maintains only current data. So current data, okay, somewhere like in some projects like they want the current data only, but anyhow, like if you want to, as per the data warehouse, if you want to analyze something, right? So if you want to do some analysis and something, so you need any history data only. Okay, so that is based on the history data only. You can do some analysis and you can do some estimations, future estimations, and something like that. So that is how the type 1 also not very useful. And coming to the type 3. Okay, in type 3, we have seen, right? So we will have a current data. There's also previous data. Okay, not previous to previous. That means a partial history. Okay, so we have seen like one example, like where we have some location, where it is a location, and location will have a current location and a previous location, right? So these two columns, like if there is a 1,000 column, 1,000 descriptive data will be there. So those 1,000 descriptive data will be repeated again in a type 3. Okay, so that will be coming to the 2,000 columns for the entire table. So 2,000 columns. Okay, that is also fine. If there is a 5,000 columns, this 5,000 descriptive columns, so it would maintain 10,000. Okay, so like this, for each column, they maintaining a duplicate column of previous column is a huge burden, right? We are maintaining a structure level of the table. Okay, having it data, it's not an issue. Okay, but maintaining the structure, like, so it should be a huge problem to the performance of the type table. So type 3 is the main disadvantage of type 3 is this thing. Okay, someone said like, okay, we will not make a complete history. That is also fine. But the main thing, like whenever any interviewer will ask you, right, what is the disadvantage of type 3? You have to say that is if we are duplicating the columns for the partial history, and we are so that the memory occupies where the table will be used in a database level. So that is how this is the problem with the type 3. Okay. And type 2. Type 2 is the main thing in our entire ETL process. Okay. And ETL process, we work with the type 2 only, where we maintain the current plus history data. So to identify the current and history data, we have a three things. What are those things?
Date, flag, and version.
Right. Good. So date, flag, and version. Okay. And version. So date is nothing but we will have what? Effective start date and
End date.
effective end date. Good. Effective end date. Okay. And coming to the flags, we will have a data like 0, comma 1. 0 is nothing but it's a inactive, and 1 is nothing but it's a active. Okay. And versioning, like just like we will maintain a versions like 0 0.1, 0 0.2, like this. Okay, so version will be increased. So maybe sometimes like 10.1, 10.2, something like that. Okay, so those are the versionings. So where we have like in an employee table where we have a separate record, the newly came record which is updated one. So we will have a effective start date and effective end date, and where come to the effective end date for the inserted record. For the first time inserted record, the effective end date will be, what is that? Infinite date, right? Infinite date will be there. Remember, or do you want me to draw the table again? Fine, right? Okay, we'll draw it again just a minute. So just like employee table, employee ID and EMP name, and what is something like salary, sorry, directly like location. Okay, here effective start date and effective end date. Okay, so employee ID some 101, and we have a some, and location is Hyderabad. Okay, and the effective start date. Effective start date is nothing but suppose we have taken like 2009 2023. Okay, what will be the effective date for insert record? It is night 12. Okay, and 31st 2020. Sorry, not 2023. 1999. Sorry, not 199. 999. So this is the infinite date for the new record. So based on this, we can assume that this record is a new record or only one record. It will not have any updated record, so that it is an active record. So suppose this employee's location is changed. So suppose the same record will be inserted again, and the location is Bangalore. Okay. And the start date will be 2022-09-2023, and the effective end date will become here 31st. This is the, and this effective start date will be going to be as a effective end date of this record, and this is going to be updated, and this is going to be inserted. Okay, remember this logic. So this logic is going to be tested in our ETL process. Okay, whether the updated records is coming like this, or effective end date is updated or not, whether effective start date is correctly inserted or not. So these things like will validate in a ETL process. Fine. So this is about the SRE types in type 1, type 2, type 3, type 4, and type 6. No doubts right here? Okay. We'll move on to the next thing, that is Yeah, fine. So we'll move to the next thing, that is fastly changing dimension. Fastly changing dimension. So in fastly changing dimension, or this is also known as a rapidly changing dimension. Rapidly changing dimension. Okay. So what is meant by fastly changing and rapidly changing? That means so somehow like here this implies the data will be updated like 6 months or 1 year, like location we have taken. This location can be changed like 6 months or 1 year, sometimes 2 years, 3 years, right? So this is not very fast changing. So somehow like there is a change, but it has a like not just like a frequent change, right? So where have some columns, where have some data table, some columns data will be changed in 2 days. There will be three times of change. Okay, there are four times of change. Or within the day, there will be multiple times of change. Okay, so that is if that data is changing multiple times and you are executing the jobs multiple times, that is a huge burden, right? So that is also, but we have to capture that data as well. That is also the main important, right? Suppose if you take an example of the patient data. Okay, any hospital, if you take, there is a patient and tables will be there, right? So this patient data maybe changes like based on the columns, based on the data we capture for the patient. Suppose this patient is available in the ICU or somewhere. Okay, and doctor may said the nurse or the someone else, right? So they are going to like capture this patient data to analyze his condition for a 1 hour, 2 hour, something like that, right? So what are the columns of that patient and how they capture the data and how we are going to split that table into the fastly changing dimension, we'll see now. Okay, suppose I'm taking an example of the patient table. Okay. And this table will have a patient ID and name, something like gender and date of birth, DOB. And here I'll write a weight. Okay. And also bliss pressure, right? BB, right? Blood pressure, BP. And there is a one more column here that is called as a updated date. Updated date. Suppose patient ID 101 only. Okay. Patient name is something like that X or something. Okay. And male. Okay. And DOB is something like 0106 0206 1988. Okay. And weight will be like it is like 90 kgs initially. And this is something like it has 160 by 100. It's not normal, right? He is a patient. So that is why. Okay. And the date, updated date is like 20/09/2023. Okay. So somehow he is admitted in the ICU, right? So if this patient, will the data of this patient will be like DOB, gender, name, patient ID. This is not going to be changed, right? So these are the sorry, these are the not going these are the static things. Okay. Where it comes to the weight and BP, so these two columns, right? So is in ICU and maybe like after 1 hour, 2 hours, this can be fluctuate. This can be low or high. Okay. And the weight after between the 2 to 3 days, the weight can be low. Okay. It can be reduced. Okay. So based on that, we will get the data of this patient frequently. That means this entire record is going to be entered one more time within the 1 hour of time or 2 hours of time. Morning they have taken the BP value and again afternoon they have taken this value only. But with that thing, the suppose I take the this is somehow it is some control I will say, and this is say something like this. Okay, and the updated date is same. If you take this as a date time as well, date time. So this is like morning. It is 10 a.m. something like that. Okay, I'm not going to write all the columns here. Okay, fine. This is something like the time will be displayed, right? And here you take it say 12 and something 09. So when it is updated, when it got updated, only between the 2 hours we have updated, we have got the updation of this BP column. Okay, but enter the other things, these are repeated again, right? So this is how if again it is going to be checked next day morning. Okay, so if you insert one more record on 01, and this name will be the same. Okay, and mail and the date of birth will be same. Okay, and the weight will be somehow like it is decreased to 85. Okay, and it got stable now. Okay, and the date is like it is 21st, and the time is same time. Here, if you observe, like only two columns are getting changed. Okay, the frequent change of the two columns is weight and weight. Okay, so instead of maintaining this all data, this can be a redundant data. We are repeating multiple times, right? So to avoid this, what we'll do, we will maintain these two columns separately, okay, and in a separate with the patient key that is known as a fastly changing dimension. So how it could be happen, we'll see now. Suppose I will take an example of this table and I'm splitting into the fastly change dimension. So that what are the static change columns here? Patient. This is the main dimension, so I'm taking as a patient details. Okay, getting right? Okay, main patient, and I'm taking these columns only, patient ID and name and gender. Okay, and DOP. So these are the static columns. I don't want to repeat again, so that is why I'm just entering this data here. Okay, this is main table and main patient table. Okay, this is known as a we are whatever the data is not going to be repeat again. That data will be entered here. Okay. Then after that, what I'm doing like for these two columns, right? Weight and BP, these two columns, I am going to make a fastly change dimension. Okay, that is also known as a patient fastly change dimension. Just like I have written. Okay, here we have a three columns. One, two is the weight and the BP, right? So where we can see the patient key. Okay, and what is that? Weight and also okay. So this is what like a patient key will be like something like 1 2 3, and the weight will be like first this record is this thing. I'm going to enter these two records here, and okay, and 132 and uh, same record 24, and this is the record for this thing. And how can we identify for these two records or the particular date or time, something like that? So for that, we will have a one more table that is patient. So relational patient. So this main patient key, so main patient table and this patient FCD. Okay, these two will have a relation between the patient relation table. Okay, based on this table, okay, this data will be we will fetch and we will do the analysis. Okay, so that is how we will have a one more table that is called patient relation. Here we will have a columns like patient ID. Okay, this is right. I'm just writing this is patient ID. Sorry, patient ID and patient key. Okay, and also we'll have a start date and end date. Okay, so patient ID, patient key, and start date, end date. What is the patient ID here? 101, right? 101. And here patient key will be 123. And what is the start date? Start date will be first date. This is so this is how the data will be going to be split. Like end date will be for this record. It is going to be infinite initially, right? So this is the infinite. So the same relation we have a one more update, right? Here 101 and the patient key 123. Sorry, patient key will be changed. Okay, what is that? 124. Sorry, 124, and the start date will be this one. Same date, start date. Here we have to maintain because date time as well, end date time as well, so that this is the start date time. And this for this, what will be the end date? So I'm taking it as a 00 for all 00s. Okay, and this is how. Okay, so now the same time and same the date. Sorry, time is different and the date is same. We have a new update. So that is how this effect to end date time will be changed to here, and this is going to be updated here because there is a change in the data of the weight and BP. So like this, so we will maintain a whatever the rapidly or fastly changing dimensions. Okay, so those dimension keys will be in a separate table and we'll make it as a fastly changing dimension. And based on that, so we are going to split the tables into three different tables. One is a main table and other is a like a patient table, we have fast chain dimension table, and other is a relation table because we have to get the data of the patient table, right? So that patient table and as well as the is condition if you want to analyze. So you need to get this weight and BP. So that is how we need a relation, but uh, and we are not going to repeat this data again and again. Fine. Got a clear picture on the fastly changing dimension? Any doubts? Okay then. So this is fine. I will take it as a no, right? Fine. So this is about the fastly changing. Now this is about we completed about the dimension types, different types of dimension. So now we look into the one fact table that is factless fact table. What is factless fact table? Okay. So till now, what we have observed. So like what is fact table means? Anyone can say what is fact table? Suppose I'm taking an example of the sales table. Okay, sales table or sales data. Okay, this is what it is. It will happen like it will have like supplier key. Okay, and this is like a product key and something like that. What product key and not fixed values. Okay, fixed values also we can say, but mostly we can say it is the facts, okay, and dimension, facts and measures. Okay, suppose it is have one more like employee key, employee key, okay, and this is known as a employee key, and this is what like amount. Okay, I will take in as a four columns. That is fine. Okay, enter columns, and this is I'm deleting. Okay, fine. So based on this, if you want to aggregate something like if you want to do the aggregation and you want to see average amount of the particular supplier, okay, average sales of the particular supplier, okay, average sales of the particular product, okay, or the sum of the sales of the particular employee. So if you want to analyze, we can go with this fact table. This is a fact table, sales fact table, facts. But where it comes to factless fact table is nothing but these measures are the numeric fields. Okay. Where it doesn't have, where it doesn't contain measures and numeric fields. Okay. Numeric data, it is known as factless fact table. Okay. So, but that means I'm saying this amount column will not be there and only dimensional keys will be there. Okay, the factless fact table will contain only dimensional keys. Even though if you have these dimensional keys, we can analyze something. What can we do analyze? What can we do the analysis from this factless fact table? Tell me, what can we do? We can do the analysis of the something like that count values, right? Something like how many products are sold by the particular supplier, how many products are sold by the particular employee. Okay, how many products are sold from the particular employee on the particular supplier. So these can be this can be analyzed by using the factless fact table, even though it doesn't contain the numerical measures. Okay, so where it comes like this is a very asking question, frequently asking question in the interviews. What is factless fact table? Okay, factless fact table is nothing but where it doesn't contain measures and numeric values, but it has a dimension keys. And if you take an example of the fact sale, okay, this fact sale will contain the columns like supplier key, product key, and employee key. Okay, so without the measures, just like an analysis of the aggregation of the particular data, something like the average, sum, k minimum, maximum. So we can do the count of the particular employees in a particular supply. That is also with one type of analysis. Okay, like this and products also we can do. As I said, like the products sold by the particular supplier, something like that. Okay, this is about the factless fact table. Clear? This is fastly chain dimension, and this is the fast factless fact table. Clear? Okay. Any doubts? Let me know. Okay, fine. So till now you can see like I'm writing about the keys: product key, employee key, supplier key. What is this? What is this key about? About key. Okay. This is called as a surrogate key in a data warehouse. Okay, you in apart from the data warehouse, you will not see anywhere in the surrogate key. Okay, surrogate key you cannot see anywhere. Okay, but what is the use of the surrogate key? Okay, why we need a surrogate? Suppose I will take an example. This is an employee table only I will take. Okay, AMP, AMP table, and here we have an employee. Okay, and the name. Okay, something like location. I'm taking. Okay, and start date and end date. Okay, so this implies data. Suppose you can take, I will assume like this is the one of the company like Capgemini implies data. Capgemini implies data. This 101 is the employee some, okay, and they can like Bangalore location, and the start date is like something like the start date is 02/04/2022. Okay, something like that. And it will be the infinite. 12/31 and 9. Infinite. Okay. And again, like this employees changed his location. 01. And again, this is the name and the location is Hyderabad. He shifted to Hyderabad. And the start date is something like that. 02/05/2023. Okay. And the effective end date will be like this. And this data will be stored here. The effective end date will be updated here with the next record starting. Fine. So this we are maintaining the history of the employee and we are maintaining like this start date, end date, something like that. Okay, fine. But suppose assume that Capgemini acquired a new company that is something like Legato or something other company. Okay, some info system, something like that. Okay, Capgemini acquired the new company. So unfortunately, what happened? The same Infosys will have a employee ID, the format of the employee ID, they follow the format of the employee IDs is the same. That means this is 101 only. Okay. But the company name is different. Okay. The firm, the employees is different. Employee is something like Narendra Saab. You will get confused. I will take a Santosh. Okay. Santosh is the name and his location is Pune. Okay. And something like and his data is something is January is something for and 2017. Okay, and effective end date will be this one. So when you are going to club these two employees data, okay, and you will have suppose like 2 lakhs of employees in this company, Infosys company, and Infosystem company, and also the Capgemini will have a 5 lakhs company employees. So totally the 7 lakhs employees will be there. Okay. And from 7 lakhs employees, if you want to get a employee who has 101, if you want to get the information of this employee, so how can you get if you fetch on like something where employee ID is equal 101, then how many employees will come? 2 employees will come from this record, right? We will get these 2 records of the Naren, and we will get a one this record of one this record of the Santosh. But if we are not seeing any name or something and location, we want to calculate there is a salaries. Here I will write one more column. Here you are calculating the sum of the salaries of the employees. Okay. So here that is 20,000, 2,000, 4,000, and here 5,000. So if you are calculating the sum of salaries of employee and you are doing something like that, employee is called 101 and the total salary of employee is something like that. What is the total of this? 6 and 5, 11,000. So that amount will become as 11,000, right? So that is the problem to identify an employee if there is a merging something and if there is the same data of maintaining here for the particular the ID or something. Okay. In that case, what we will do, in a data warehouse, there is a one more column will come that is called employee key. Here we will maintain a employee. Okay. For each record, there will be one data. 1, 2, 3. Suppose simply like I can say like 100, I will start from. Okay. 101 and 102. So like this, we'll maintain a records of with the employee key for numeric data. Whenever this data is entered from the Informatica, right? So as I said, like just explain the diagram. So what I said for initially, we will have one source. Okay, from source we will get the data into the staging area, and from this staging area we will load the data into the target. Okay, first thing, imagine that this is the first record is scheme and first record is when enter into the target. What is that first record? It is like so 101 record, 101 record, and its location is initially Bangalore, right? Bangalore location data and 101 and Bangalore, and this data will be going enter, right? So this time the key will be assigned to this record 101 and okay, and next time same record, right? 101 is updated here in the source level, and his updation will be came like in a staging like Hyderabad. Okay, and this data will be entered with a different key. 101 is the key, and 101 is the is ID, and the location will be Hyderabad. Okay, like this for every insert. Okay, for every insert in a data warehouse, the key will be assigned to the this table. Got it? So this is the what I can say the surrogate key is the global identification of a particular record is known as a surrogate key. Okay, wherever somehow like after 1 year or 2 years, some other company is acquired, and in that company also, if you have the same employee ID format, okay, so then that is also a problem. So that why, so in data warehouse, not only these things, so instead of using these IDs, okay, instead of this using IDs to identify a particular record or a particular employee or a particular product or a particular sale, so we are going to use the keys in a table, okay, that is known as a surrogate key. Okay, so this is surrogate key. How it is available in the fact table is nothing but, so suppose this is a dimensional table, right? This is a dimensional table. Okay, in a fact table, if you want to know the sales of an employee, okay, so I will take an example of the sales fact sale or something. Okay, this is a fact sales. Okay, and this key here we will have a EMP key, not employee ID, employee key we will have, and if there is a one more table, okay, I will have one more table that is product. This is a dimension table, dim product, product, and here we'll have a what is that product key and product ID and product name and whatever the start date end date we can maintain. So I'm just writing the start date. Okay, and the keys will be like 201, starting with 20. Okay, the product ID like 401 or something. Okay, and the product name something like that, something laptop or something. Okay, laptop, and the start date is something. Okay, so this key, product key, product key will be maintained here. So, and whatever the amount, right? Amount sold by the particular employee on a particular product, this amount will be available here. The keys will be like, sir, 101 will be here, and is a product is key is 200, and the amount is 1000. Okay, and same time to the below. and the 101 is this product sale product. Okay, and 2000. Okay, so when there is a, you are going to look into the particular employee, right? So this particular employee sale data, right? So now what is happening? This key is right. Whatever this key is going to be have a join with this key. So it is looking for this key 101 and 100, and this zero, and it is taking one key, product key. This product key will be going here and check for the laptop and whatever the information, then after that, it will calculate the total salary of amount. Okay, this is what happens in a data warehouse. Okay, so always we take the fact table as a base table. Here, from here, we will take one employee key, and this employee key will be going to check for the employee's data. Okay, whatever the salaries and all those things, it will get the data. Then after that, once we got the data from this here, and it is going to be check which product key is associated with the this employee key. Okay, this product key is associated with this employee key, and this product key will be going to search here which product or product name or product ID, something like that, I started or something like that. So that will be taken care, and for this we can get the employees product and the total amount of the particular employee product sale. That is how the database data warehouse will work to analyze something by using this surrogate key. Fine. Any doubts here? No? Fine. So this is the main concept. Okay. Where why this what is this product key or something like that, right? So these product keys are the primary keys. We in a when coming to the database classes, right? SQL classes will look into the what is a primary key, foreign key, and what are the constraints available in the product database. That those are will look into. So and also we can't make this primary key like this. It's okay, 101, 101 like this. We can't make this duplicate, but why are making here so that we will see into the SQL classes. Okay, this is about the surrogate key. Factless fact table and fastly gene dimension and surrogate key. Okay, the next thing is we are going to learn about these schemas. Okay, what is schema? Anyone know? What is schema? Suppose if you are going to construct a house, right? If you are going to construct a house, what will you have? Like, how can we design like something? So you will have some blueprint, right? So how the house will be like, where it could be, calculation of a table. No, it is not a calculation, right? Something. So it is a different thing. Like suppose if you, I just said an example of you are going to build in a house, you have some structure, right? So where the particular things like yes, exactly, just like a plan. Okay. So suppose like you want to make a hall should be here, and according to the Vastu Shastra, you will take something else, right? So the hall should be here, and the bedroom should be here. And we have to maintain the something like cupboards here, something like that. So the kitchen should be here. So that is called as a blueprint or something like that. So while we are going to construct a house, you will have some like a soft copy of that construction of that, how it is going to be designed, how it is going to be constructed, that design you will have, right? The same way, if you are going to build a data warehouse, okay, if you are going to build a data warehouse, you will have some idea, right? So where the fact table should be there and where the dimension should be there, and what is the relation, how the relation between the dimension and fact table, and those things you have to analyze first. Okay. Then after that only you will go with the best performance. Otherwise, if you are building the dimension tables, if you are building the fact tables, and it has something like that, so in a various like dimension will have a relation between the other dimension, and this dimension will have a fact table, and fact table will have a relation with the other fact table. So it is a clumsy, right? You can't do the particle analysis on the data. Okay. So instead of that, we have to go in a process that is like a logical structure, we can say, of a schemas. Okay. So any database of logical structure is nothing but a schema. Okay. So in data warehouse, we have a three type of schemas. One is star schema. Okay. And two is snowflake schema. Okay. And third is galaxy schema. Okay. Snowflake schema and galaxy schema. These are the three types of schemas available in the data warehouse. Okay. So how these schemas will be will have a so this is based on the relation between the dimension and fact only. Okay. These are divided into the how these are divided into the schemas and different type of schemas, something like that, right? So these are based on the relation between the dimensional factor. Okay, so this dimension, see, if this employee is a dimension and this dim product is a dimension. Okay, so this dimension relationship, how this dimension relationship, and how this dimension relationship with the fact table. Okay, so based on this, these schemas are divided. Okay, so tomorrow we will see about these schemas, okay, and how the relation between the dimension and fact tables. Okay, so that we can divide that which is star schema and which is snowflake schema and which is galaxy schema. Okay, till now it is fine, right? Any clarification? Not only this class, so in the previous class also, if you have any doubts, please let me know. Yes, clear. So, and with this schemas, right, we are going to complete the data warehouse concepts. Okay, so we will start the SQL after this. If we start with the normalization thing first, what is normalization and what is the techniques of normalization? Then after that, and how the data warehouse is denormalized and the database is normalized. Those things we will see. Then after that, we'll enter into the complete SQL, structure query language. Fine. Okay. That's it for today. So if you do not have any doubts, so we can close this call. If you have any doubts, please let me know. We'll have a time. Let me know. Any doubts? In previous class also, if you have any doubts, let me know. Okay, then I think no one has any doubt. Okay, so that's it for today. Have a nice day, guys. We'll meet tomorrow.